Right now, somewhere in a room full of strangers, your body already knows if someone is looking at you, not your conscious mind. Your body, before you turn your head, before you even think about it. This isn't a guess. This is measurable. Think about the last time you were in a crowded place, a train, a classroom, a busy street. At some point, you probably felt it, that strange pull, the sense that eyes were on you, and when you turned, someone actually was looking. How did you know? You hadn't seen their face yet. You hadn't heard anything. So what exactly tipped you off? The real answer is stranger than instinct. It's a specific, dedicated system built into your brain for one job only, detecting when another set of eyes is pointed directly at you. Scientists call it the eye direction detector. It's not part of your general vision. It's a separate, specialized circuit, and it runs constantly in the background, even when you're not paying attention to anything in particular. Your peripheral vision, the blurry edges of what you see, is unusually good at one very specific thing, picking out the shape of two dark circles pointed straight at you, even from far away, even in a crowd, even when everything else in view is out of focus. Where did this idea come from? In the 1990s, a researcher named Simon Baron-Cohen proposed that humans have a built-in mechanism just for this, something he called the eye direction detector. He argued it was one of the earliest and most basic parts of how we understand other minds. Before you can guess what someone is thinking, before you can read their emotions, you first need to know one simple thing: are they looking at me or not? Baron-Cohen suggested this system developed so early in infancy that babies only a few days old already prefer to look at faces with open, direct eyes over faces with closed or averted eyes. Why would evolution build something this specific? The answer goes back long before humans existed at all. Think about any animal being watched by a predator in the wild, a rabbit in a field, a fish in shallow water. For that animal, noticing a stare a half-second earlier can be the difference between escaping and becoming a meal. Across the animal kingdom, prey species show a strong, automatic response to the sight of eyes, even eyes drawn on paper. Moths have evolved giant eye-like patterns on their wings for exactly this reason, to trigger the same ancient fear response in predators that would otherwise eat them. Humans carry this same ancient wiring, just repurposed. We're rarely being hunted by predators anymore, but the circuit that once scanned the grass for a lion's stare never went away. It just found new uses. This is where the deeper neuroscience comes in. A researcher named Michael Graziano studied how the brain processes gaze and personal space together. He found that certain neurons in the brain fire specifically when something, an object or a gaze, approaches your body within a close range. And gaze itself lights up regions like the superior temporal sulcus, a part of the brain that tracks not just where a face is, but exactly where its eyes are pointing. This region can calculate another person's line of sight almost instantly, and it feeds that information straight into your amygdala, the brain's alarm system. That's why direct eye contact from a stranger can spike your heart rate before you've consciously registered anything at all. Your brain treats a locked gaze as a potential threat, first, and a social signal, second. So the feeling of being watched isn't imagination. It's your superior temporal sulcus and your amygdala working together at high speed, long before your prefrontal cortex, the slow, conscious part of your brain, catches up and lets you know what's happening. Here's where it gets even stranger. This system is so sensitive that it responds to eyes that aren't even real. A researcher named Melissa Bateson ran a now famous experiment in a university coffee room. For weeks, she alternated a picture above the honesty box where people paid for their coffee, sometimes a photo of a pair of eyes, sometimes a photo of flowers. On the weeks with the eyes, people paid nearly 3 times more into the honesty box than on the weeks with flowers. Nobody was actually watching. It was a printed photograph. But the eye detection circuit in people's brains didn't fully distinguish between a real gaze and a picture of one. Just the shape of eyes pointed toward them was enough to change their behavior, without them ever consciously deciding to be more honest. This tells us something important. Your gaze detector isn't just about safety. It's tangled up with your sense of being judged, watched, and held accountable. Eyes, real or not, activate the part of you that behaves as if someone else's opinion matters right now. And here's the twist nobody expects. You'd assume the people most sensitive to being watched would be the most anxious or self-conscious ones. But research on social attention shows something closer to the opposite. People with strong social skills tend to detect gaze faster and more accurately than people who struggle socially. In autism research, for instance, one of the more consistent findings is reduced sensitivity to eye contact and gaze direction. Not because those individuals care less about people, but because that specific detection circuit processes the signal differently. Being highly tuned to someone else's stare isn't a weakness or an insecurity. It's a sign that your brain's social radar is working exactly the way it evolved to. So every time you feel that unexplainable pull to turn around in a crowd, and you're right, someone actually is looking. You're not imagining it, and you're not being paranoid. You're running a detection system older than language itself, a system built specifically to answer one question before any other question matters: is someone's attention on me right now? But now the mirror flips toward your own life in a way that might unsettle you a little. Think about video calls. Something about them feels exhausting in a way in-person meetings often don't, and gaze detection is part of the reason why. On a video call, everyone's eyes appear to be pointed at the camera, which your brain interprets as pointed directly at you, constantly, for the entire meeting. In a real room, people's gaze naturally drifts to their notes, to another person, out a window, giving your ancient detection system moments of rest. On a screen full of small rectangles, that system never gets to relax. Every face looks like it's staring at you the whole time, because in a sense, it is. Now think about the cameras built into your phone, your laptop, your doorbell, your smart speaker, even when you know intellectually that no one is watching through them. At this exact moment, some studies on the watching eyes effect suggest that simply seeing a camera lens, something shaped roughly like an eye, pointed in your direction, can trigger the same subtle self-monitoring behavior that Bateson found with printed photographs. Your gaze detector doesn't fully know the difference between a human eye, a printed eye, and a small glass lens. It just sees a dark circle aimed at you and quietly assumes it might be watched. And this explains something almost everyone has felt at some point: that strange stiffness when you notice a security camera above a store entrance, even though you've done nothing wrong. Or the odd self-consciousness of walking past a large window where someone could be looking out, even if no one actually is. Your body isn't reacting to any real threat in those moments. It's reacting to shape and direction, the same ancient trigger that once helped a distant ancestor survive a predator's stare in the grass. So the next time you feel eyes on you in a crowded room, or catch yourself sitting up straighter the moment a camera appears, don't brush it off as nerves or overthinking. That's not a flaw in you. That's one of the oldest alarm systems your body owns, still scanning, still calculating, still doing exactly the job it was built to do, long before you were born and long before you ever learned to notice it running. And right now, wherever you are, somewhere close by, someone's eyes might already be on you.